The sight of small aircraft flying around our skies is a familiar one to most of us. These small general aviation, or GA planes, are favorites of private pilots, small businesses, and flight schools because of their relative low cost and the freedom they provide. Although these aircraft are very safe, about 1,600 of them are involved in accidents every year, and quite often, these accidents can be fatal. In an effort to prevent many of these accidents from becoming fatal, NASA has funded an innovative program which uses a ballistic parachute mounted on the plane, which when deployed can actually save the plane and the passengers from a catastrophic accident. I spoke with Lisa Jones at NASA Langley Research Center to find out more.
Parachute recovery systems are not new. They've been used to return our astronauts from the moon, the Apollo program for instance. They've been applied to the military aircraft such as the F-11 crew escape module. It floats down on a parachute recovery system. Now they're being applied to general aviation aircraft. And in the structural designs, this is a good way to save money and weight because you can actually design a structure to support the parachute system.
The parachute works like this. During an emergency event, if the pilot feels that he's about to lose control of the aircraft or has lost control, he must turn off the engine, then simply pull firmly on the parachute release handle located above his head. The parachute, which is propelled by a solid fuel rocket motor, is released from a special opening on top of the fuselage. 3 Kevlar straps connect the parachute to the airframe and help slow the aircraft, guiding it through a level descent. Although the parachute system already has 155 saves with ultralight aircraft, the first save in a general aviation plane came in October of 2002, with the aircraft suffering little damage and the pilot walking away from the crash with no injuries at all. So Lisa, is this parachute system just for new aircraft or can it be retrofitted on older planes?
Parachute system design can be incorporated into older aircraft designs. It's just you would have to do some modifications to the structure, make sure that the structure could handle the loads the system puts on the airframe, and also be certified for it.
Lisa, what are some situations where a pilot would need to use this device?
As a pilot can tell you, there's many times when things will go bad quickly when flying. So there are many different scenarios where the system may be deployed.
Some situations where a parachute recovery system could be used are loss of control of the aircraft due to icing, engine failure, and airframe structural failure. One of the most common causes of general aviation aircraft accidents is pilot disorientation. Many pilots are only rated to operate an aircraft under visual flight rules, or VFR. But in order to fly in bad weather, a pilot should also be able to fly under IFR, or instrument flight rules. If a visual flight rules rated pilot encounters weather where he can't see visual landmarks outside the plane, then spatial disorientation can occur. When this happens, the pilot literally cannot determine if his plane's in level flight or if it's turning or banking. Very frequently, the VFR pilot will rely on his instincts rather than his instruments, which can lead to a catastrophic outcome. With the parachute recovery system on board, no matter what the situation, the pilot has one last best option to save not only the aircraft, but most importantly, the lives of everyone on board. I know this is being used for general aviation aircraft, but is there a chance that it could be used on larger planes?
I think it can be applied to some of the business jets where you're talking about 10, 12, 14 passenger perhaps. That would have to be really investigated closely. But for application to a transport, you're not going to see that. The structural requirements for the aircraft would be enormous to handle that, as well as the design characteristics for the chute itself to be able to take the energy of a large transport. So you're not going to be able to use this efficiently on anything of much size greater than a general aviation aircraft.
So Lisa, why is NASA working on this type of project?
NASA has a program called the Aviation Safety Program. And in that we're looking at different types of things to improve safety everywhere. Some of that in the early part of the program was focused on general aviation. There are 1,000 lives a year lost to general aviation accidents. And this type of system can really improve those numbers and hopefully get those down where we see a lot more people walking away from accidents.